Good evening, everyone. Welcome to week 9. Sorry. Okay, good evening, everyone. Welcome to week 9 of Alisat's Logic and Systems and Applications. I'm your teaching assistant. My name is Haladi Pravalika. I'm a PhD student and a Prime Minister Research Fellow from the Indian Institute of Science. So, before we begin our common set of instructions, this session is being recorded. And please be respectful during the session, during the chat box, and when asking questions and all such things. Okay, so put all your questions in the chat box and I'll be answering them. So for today, it's not a complicated topic. We do have very less topics and very less number of questions to solve. So hopefully we'll finish everything by 7, but I'll stay till 8. And in case if you guys have any questions, drop it in the chat box and I'll immediately answer. Okay, so with that, let's begin this week's content. So this week, we are looking at linguistic hedges. So, before we understand what linguistic hedges mean, so you need to understand the word linguistic. So, linguistic is the study of language or the human speech, right? So, how are we forming the sentences and what we are using? So, if I'm saying I am fine, so what? Why am I saying it? I am fine. Why ain't I saying it as I is fine? Right? We do have some set of instructions like a syntax in code. We also do have some conditions in our sentences, right? So the study of these languages that we use is called as linguistic. So if in case, for example, if you know more than one language, that is two languages, they say bilinguistic, right? So similarly, this as well. Okay, so that is linguistic. And there is another term called as quintuple, so which means having 5 units. Okay, so we will understand why we are using a quintuple. Okay, and then we have something called as a linguistic variable. So this linguistic variable is characterized by a quintuple, which means it has total of 5 units or 5 measures of 5 variables. Okay, and all these 5 variables are given here as x, t of x, capital X, G, and M. You already know what a small x gives, right? We call a small x as a generic variable, but here we call it as a linguistic variable. It's similar to that of a generic variable, actually. Okay, and then we have t of x, which is term set. So if I am saying we are discussing about maybe places, okay, then we can say what Paris, London, Mumbai, Hyderabad, America, California, all these places, right? So these all are terms, and I can put them in a set, and hence I can call it as a term set, right? But these are all are like different places. But in these examples that we see, we'll be sticking to a particular area whenever possible. So, for example, if we are saying age, okay, I can say a toddler, a newborn, toddler, a teenager, and then mid-age and old age, like that. Multiple things, right? So these all are terms. So if I put all of them into a set, it is called as a term set. So we have x, we have t of x. So far clear, right? And then we have capital X. We all know what a capital X is. That is our universe of disclosure, right? So that is our capital X. And then we have another two variables called as G and M. So G is a syntactic rule. So if we are talking, whenever we are making a sentence, we have a certain set of rules, right? If I'm using plural, then I have, let us we or they. I have to use the word are. You are, we are, they are, right? That's syntax. I cannot say you is, we is, right? So some sort of syntax we do have when we are forming a sentence. So similarly, in this also we have a syntactic rule. And then we have a semantic. So semantic is basically how you make relation between you are forming a relation to a meaning in any language or a logic. So let us take my age. Okay, I'm not too young and I'm not too old. Okay, so I cannot be considered as too young. I cannot be considered as too old. I'm somewhere in between, right? So I'm not too young, and the word "and" is a semantic relation, and I'm not too old. So there is a relation that I'm forming between two sentences: too young, too old, right? So this is how we form a linguistic hedge. Okay, I hope I'm clear so far. Okay, so let us look at an example. Here x, which is our linguistic variable or a generic variable. And here we are taking an example of height. Okay. And what all terms can be associated with height? I can say a person is too short or just short, or he has an average height. Or I can say the person is tall, or I can say the person is too tall. Okay. If I'm talking about someone who is 3 feet, I can term them as too short. If I'm considering someone of my height, 5 feet, then I can say them as short. And if I see someone like 5'4" or something, then I can say they're of average height. And if I see someone almost near 6 feet, I can call them as tall. And if someone is about 7 feet or something, then I can say they're too tall. So all of these terms, too short, short, average, tall, too tall, all of these are different terms in a given set. So that is our T of x. And since x is height for us, we write it as T of height. And then we have all the value, all the terms. So these terms are called as linguistic terms. Okay. So this is a example for us. Okay. So now let us look at what a linguistic variable is. Okay, so linguistic variable can be classified into three groups. The first group is a primary term. So primary term indicates if we are still dealing with height, I can say a person is short, average, tall. Okay, I'm not telling is that person too short or too tall. I'm just not saying anything. I'm just using some primary words without making emphasis on whether they are too short or too tall or things like that. Okay, so the primary terms here include short, average, and tall, right? And then we have linguistic hedges. So linguistic hedges are nothing but adjectives. So I can call a person as too tall, too short, very tall. Okay. So whenever I put some sort of an adjective in between, that is a linguistic hedges. And then we have negation or complement. Negation or complement is opposite of what we are saying. He is not tall, he is not short, like that. And then we have connectivities. So connectivities here are, let us say, a person is of average height, and you have to describe him based on short or tall. So what can we say? We can say the person is not too short and not too tall. He's not too short, not too tall. He's somewhere in between. If we want to say something in between, then we use a connective word and or but, things like that. And or all of these are connectivities. So these are the groups of linguistic variables. And then coming to linguistic hedges. So how are we going to deal when we have a fuzzy set uh, and we want to apply a very or more or very, which is extreme, and things like that over the given fuzzy sets. Okay, so we'll look at it. So as you know, we write our A as a summation of small x, which belongs to capital X of universe of disclose. And then we have our membership function for a given value of generic variable, right? So this is our A. And if I'm saying that, let us call this as height or tall. So here I'm saying too tall. Okay? Let us say our A fuzzy set here represents tall. And if I want to know a person who is too tall, okay, then what we have to do is you have to replace this nu of A with nu of A whole square. Very or 2 have to be take it the membership value have to be powered by 2. Okay. And in case if I'm asking you about more or less, I want to convert something, fuzzy set A to more of A or less of A, then I have to take the square root of the membership values. Okay, so that is for more or less. And if I'm saying very, very, very for 3 times, which means in place of very, 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 you can also use extremely. So for one vary, you are squaring it, right? So now we have 3 varies. So for the first vary, it is nu of A of x whole square. For the second vary, you have to square this. And for the third vary, you have to square once more. So now you have 3 times, you are squaring the same membership value 3 times. 2 into 2 into 2, which is basically 8. You're basically uh, multiplying it for 8 times. Okay. So in place of extremely or in place of very, 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 you use it, you take the power 8 for the given membership value, right? So in case if I give very for let us say 2 times, right? Then it is supposed the power is supposed to be 4. Okay. Okay. Let's do an example. Here, let us say there we have a linguistic variable called as common, and then we have a universe of disclosure as 1, 2, 3. And the fuzzy set of common is 0.7 given 1, 0.1 given 2, and 1 given 3. So I want to know about very common. Okay. So let's do this one together. Okay. So the first one is very common. So very here, you have to take the power of 2, right? So very common is equal to 0.7 whole square for given 1 and 0.1 whole square for given 2, 1 square for given 3. So this is equal to 0.49 given 1, 0.01 given 2, and 1 given 3, right? So can you guys do for very, very and let me know what's your answer? Can you do for very, very common? Any answers for very, very common? Okay, I'll give you a minute. Yes. Thank you, Amber. You're right. Okay. So for very, very, we have to take 2 to the power 2, right? So we are going to take the total of power 4. So for very, we take nu of a of x whole square for a given x. That is for very. So for very, very, this common, we take squares of square, right? Yes, Yamuna, you're right. Thank you. So which is going to be nu a of x to the power 4. for a given value of x, right? So for a very, very common, we have 0.49 whole square for given 1, 0.01 whole square for given 2, and 1 square for given 3. So this is equal to 0.2401 for given 1, and this is already 10 power minus 2. So 10 power minus 4 given 4, sorry, 2, and 1 for given 3, right? So this is a very, very common. So now, can you do extremely common? For the same thing, extremely common. Okay. Uh, Yamuna, can you see? Can you check the uh, membership variable? Sorry, membership value for uh, variable 1, x equal to 1. Right. Okay. So for extremely common, we take triple vary, right? It is very, very, very. So which means for triple V, we take mu a x to the power 8 given x, right? We'll see. Uh, yeah. So it is going to be 0 0.7 to the power 8 for 1, 0.1 power 8 for 2, and 1 power 8 3, right? Okay. Let me just take the power. 0.0576. 0.0576. Okay. Yamuna, you're right. Sorry. Yeah. For given value of 1 plus 10 power minus 8 for given 2 and 1 given 3. 1.0. Okay. So this is for extremely common. And then can you do for less common? Just in case if you need it, need the fuzzy set here. Can you do for less common as well? So for less common, what do we do? Do we do square or do we take a square root? Square root. Yes, Yamuna. Thank you. Yeah. So for less common or more common, we take the square root. 0.7 for 1, 0.1 for 2, and square root of 1 for 3. 0.7, it is 0.84 for 1. Okay? And square root and 0.316 for given 2 and 1 given 3, right? So this is a less common. So this is also going to be for more common as well. Okay. For less common or less or more, we'll take the square root. For vary, we take square. Okay. If we are saying vary twice, then we take the square root twice. If we say vary thrice, or if we use the word extremely, then we take to the power 8. Okay, we square it for 3 times. Okay. Okay. So now we'll look at negation and complement. We all know what a negation or a complement is. So it's basically opposite of what we say. So for a given fuzzy set A, if we are having a membership value of new A, and if I want to know the complement of that value, then I take 1 minus new A, right? Similarly, here also we have not of A. So that is, we take the opposite complement of A, and then we write it as 1 minus new A of X for a given X. Okay, so that is a negation or a complement. And then we have connectives. So connectives include and, or, and but. Okay. And but both will take intersection, as we all know. And for or, we use the union. So when we say intersection, we take the minimum membership value between given fuzzy sets. Sorry, membership values of the fuzzy set. And then for or, we take the maximum value for a given two membership values, right? I hope you all remember this from our previous classes, right? So here I have given two fuzzy sets, okay? So A and B. So first thing is I want you all to find the complement of A, okay? Let's do it together. Okay, so the first one is complement of A, which is equal to, so it is 1 minus 1.0 for given 1 plus 1 minus 0.7 for given 2 plus 1 minus 0.3 for given 3. So which is equal to 0 for given 1, 1 minus 1 plus 0.3 for given 2 and 0.7 for given 3. So the final is 0.3 for given 2 and 0.7 for given 3. Right? So that is a complement of A. Can you guys find A and B? What is A and B? A intersection B, that is equal to minimum of mu A and mu B if summation x belongs to capital X for a given X. Right? So that is our A and B. So let's do that. A intersection B. So we have 1 intersection 0.2 for given 1 plus 0.7 intersection 0.3 for 2 and 0.3 intersection 0.4 for given 3. So this is going to be 0.2 for given 1, 0.3 for given 2, and 0.3 given 3. So this is a AND. So let's do for OR. A or B. So A or B is, you take the union. So union is nothing but maximum value for two given membership functions. Sorry, membership values, right? For a given X. So let's do that. A union B is equal to, sorry, I lost the values. 1 union 0.2 for 1. Oh, okay. Next 0.7 union 0.3 for 2. 0.3 union 0.4 for 3. Yes, Yamuna, you are right. So it's 1 for given 1 plus 0.7 given 2 plus 0.4 for given 3. So this is a or B. Okay. Next is we have something as A and of A or B. So it's like A and A or B. So if you apply your Bottomless rule, the brackets are usually the first ones to be solved, right? So first you solve for A or B. So we already have A or B here, right? So it's basically A and all these values, 0.1, so this 0.7, 0.4, and 3. Let me bring A from here. We already have A, right? So and is basically we are going to take the minimum values. So it's going to be 1 intersection 1 for given 1 plus 0.7 intersection 0.7 for given 2. Oh, both the values are actually also 0.3 given 0.4 for given 3. So it's going to be 1 for 1. Yes, Yamuna, you're right. 0.7 for 2. 0.3 for 3. Right? So this is how we do. Now good. So that is so far regarding the negations and as well as the connectivities, right? Any clear, so sorry, any doubts so far? Thank you so much. Okay. So next we'll be looking at concentration and dilation. So concentration is basically you are raising the power of the fuzzy set to some value of k, where k is greater than 1. Okay, so the k values can be 2 or 3 or 4 or anything. Okay, you are basically increasing the concentration. So in place of A, you are going to have A of k, right? So you are increasing the concentration of the original fuzzy set A, where k is greater than 1. Okay, when k is less than 1, we call it as dilution. But when k is greater than 1, we call it as concentration. So the concentration here is represented as like this. So you take the membership value and then you raise the power of the membership value to k. Okay, for a given x value. Okay, if the k values are not given and if it is told, if it is just told to find to get the concentration of fuzzy set A, then you directly take k is equal to 2. So k equal to 2 is the default value. Okay. Oh. So let us have a look. This is our new values and this is our x values. Let us say we have A of this sort. Let us say A is like this. So if I want to find the concentration of A, essentially what happens is that the spread is going to decrease. Okay, so this is let's say A square. Okay, you take any membership function, you plot any fuzzy set, okay, a continuous one in MATLAB, and then you square the values and plot the same thing in the same plot. Okay, plot A square in the same plot, and then see the difference between A and A square. The spread is going to decrease when you increase the concentration. And the opposite happens for dilation. Okay. When you do dilation, the spread will increase. But when you do concentration, your spread will decrease. Okay. Now, let us try this example out. Okay. Okay. Just change the values. Let's say k equal to 3 and k equal to 5. Okay, 5 will be a little too much for now. Okay, let's just stick with k equal to 3. Okay, so for A3, it's going to be 0.3 cube for a 1, 0.6 cube for 2, and 0.9 cube for 3, right? And 0, okay, it's going to be 10 power minus 3 in 7 for given 1. Here I need this. This 0.216 for 2, and then 0.729 for 3. Okay. So if I say k equal to 5, then A5 is equal to 0.3 to the power 5 for given value of 1, 0.6 to the power 5 for given value of 2, and 0.9 to the power 5 for given value of 3. Okay. So this is how you find the concentration. Now let us look at dilation. So dilation is just the opposite of concentration in every aspect. Okay. So if I say, if I give you a fuzzy set A, and if I say dilute it without giving the value of k, then by default you have to take the k value as 0.5. Okay, until and unless I mention some other value of k, let us say k equal to 0.3, only then I have to take the membership value and take the power 0.3. Until and unless the k values is given, you always take 0.5. So here, let us look at this. And before we get into the example, whenever in a question, if you are asked uh, to slightly, if the word slightly is used, then you have to do dilation. So in the common example that we have looked earlier, right? Very common, very, very common, extremely common, or that we have seen here. So in place of all those very common, very, very common, or less common, or more common, if I'm asking for slightly common, slightly here indicates that you have to take the dilation. Okay, for the default value of k. Dilation for the default value of k, that is 0.5. Okay, so here we have a fuzzy set A, and no k value is not given. Hence, we have to take 0.5. Square root of 0.3 for 1, square root of 0.6 for 2, and 0.9 for 3, right? 0.3 square is 0.55 for 1, 0.6 square is 0.77 for 2, 0.9 square is 0.949 for 3. Okay, so this is how you find the dilation. Again, I'm repeating. For concentration, you square it as a default. For dilation, you take the square root as a default. Okay, until and unless the k values are specified. Okay, sometimes you might be just asked as k equal to zero point 0.2. Okay, is it going to be dilation or concentration? If I say k equal to zero point 0.2, which is less than 1, basically we are dilating, right? And also the spread is opposite to what happens in concentration. The spread here in dilation will increase. So this is the spread of A. This is going to be the spread of 0.5. Okay, the spread will increase. Okay, so the last topic that we have come for now is composite linguistic terms. So this is something that we have seen in the beginning also. Okay, so the first one is not very young and not very old. So here, let's identify groups. Okay, the primary terms are very young, very old, and the connective word is and. Sorry, and, or if I use or, then that is also a connective term. If I use but, it's also another connective term. So depending on the sentence, you use or and or but, and those all are your connective words. Okay, and then negative, negation. The negation word that we have in this sentence is not. Right? So we have not, we have very young, very old, and we have and. Right? So we have all the different groups. So here, let's look at an example. Young, but not too young. So for example, let us say I'm giving you a fuzzy set as young. Okay. Maybe 0.2 of 1 plus 0.3 of 2, something like that. Okay. And I'm given this sentence to you. And I want you to find the fuzzy term set. How do you do it? First, you start with too young. Okay. Too young is basically you take this and you square it, right? So too young is done. And then you go for, okay, let's put it as one. And then you go for the word not. So then you take the negation of that squared fuzzy set you just got. Okay. And then here you have young. Young fuzzy set is already available. So this is one. And this is your young, too young. And then not too young. You have the negation set. So you have this, you have this, and then you have the connectivity term, but. So, but is also like and, you are going to take the intersection. You're not going to take union, you're going to take intersection. So you take the intersection between this fuzzy set and the fuzzy set that you have obtained over here. Okay, you take the intersection. And that is how you get your final fuzzy term set. Okay. Okay. So with that, I'm done with the content part, theory part. Any questions so far? Any questions from whatever I have discussed till now? Any questions or anywhere that you couldn't follow so that I can discuss again? Okay. So I'm now I'll jumping to the previous year assignment questions. Okay. So for the first question, I have a linguistic variable and it's called Daisy. Okay. And then I have a universe of discourse with the values 1, 2, and 3 and 4. 1, 2, 3, and 4. Okay. And then I have a fuzzy set called lazy for 1 given 1 plus 0.5 given 2 and 0.3 given 3 and 0.2 given 4. Okay. And I need you to find what is very lazy. So the lazy fuzzy set is given and I want you to find very lazy. Okay. I'll give you a minute. Try to find the answer. give me the answer. I'm deliberately not adding the choices here because today's class is really easy. Yes, Yamuna, you're right. Okay. So very lazy means you have to take the square of the given membership values. So it is 1 square, so which is going to be 1 for given 1, and zero point 0.5 square, which is going to be 0.25 for given 2, and zero point 0.3 square, which is going to be 0.09 given 3, and zero point 0.2 square, which is going to be 0.04 given 4. Right? Okay. Now, for the same lazy set, find more or less lazy. More or less lazy. Thank you, Janani. You are right. Okay. What will be more or less lazy? Okay. Thank you, Amber and Yamuna. Okay. So we'll see more or less lazy. So which means you have to take the square root. Right? So 1.0, 1 square root of 1 is 1 plus square root of 5 is 0.707 for 2 plus, and then we have 0.3, 0.54 plus 0.2 square is 0.447. Right? Um, yeah. Amber and Yamuna, both of you are right. Okay. So for more or less, we take the square root. Okay. Yes, for slightly lazy also, we'll take square root. I have already mentioned it when I was discussing dilation. Okay, whenever there is a word slightly, even then you'll take square root. Okay, okay. Then let's look at very, very lazy. So for very, very lazy, what do? You take mu of a to the power square of square for given x. So that is equal to summation of x given x, mu a of x, the power 4 for a given x. Right? So this is equal to, okay, what 1.0 given 1. Okay, let's see. 0.6 0625 for given 2. Thank you, Yamuna. You're right. 0.0081 for given 3 and 0.0016 for given 4. Right? So that is our very, very lazy. And the last one is not lazy. Not lazy means we have to take the negation, right? So negation of whatever is the lazy values. So that is equal to 0 for given 1, 0.5 for given 2, 0.7 for given 3, and 0.8 for given 4. So which is equal to 0.5 for given 2, 0.7 for given 3, 0.8 for given 4. Right? Clear so far? Okay. Now, let's go for another set of questions. So we will be given two fuzzy sets, A and B. Okay, and then you'll be asked to find and or. Okay, A and B and A or B. Okay, and there might be other ways also, like asking A and of A or B, or A or of A or B, and things like that. Okay, so you have to be prepared. So you have to follow whatever is there in the bracket. You have to solve for that first, and then you have to go for the remaining. Okay, always keep that in mind. But for here, it is simple question. You just have to find and then you have to find or. Okay, I don't think I have to give. Have to like write the answers here. Maybe you guys can try this out for yourself. Right? This is a simple and or operations. So it's A and B, A intersection B, that is equal to minimum of mu A of x, comma nu B of x, okay, for all x value, for all x in capital X, right? So for A or B, you take union. So that is, you take the maximum membership value for all x belonging to capital X, right? You can solve. If anyone wants to give answer, I'll be happy to look at it. Okay, good. And the last question is, um, when we want to find how is slightly light obtained from light. So here light is a linguistic variable. Okay, that is say you have a fuzzy set and the name is given as light, and I'm asking you, how do we find slightly light? Yes, Amber, you're right. So we are given a couple of options. First is concentration, second is intersection, then dilation, complement operation, and none of the above. So whenever the word slightly is used, or more or less is used, then we always go for to the power 0.5, which is nothing but default dilation, right? So dilation is your answer. So with that, I'm done with the previous questions as well. Okay. Any other questions from today's class? And B 0.5, 0.5, 0.3. Amazing, Janani. You're right. For A and B, it's right. Thank you, Yamuna. Just write your answers here. Sorry. A union, sorry. A and B, 0.5, 1, 0.5, 2, 0.3 of 3, 1 of 4, A or B, 1 of 1, 1 of 2, 0.7 of 3, and 0.2 of 4. Okay. So yeah. So if there are no more questions, I am done with today's class. In case if you have any questions for me, do let me know in the chat box. Okay. And if there are no questions, thank you all for joining and thank you all for being really attentive. Okay. Thank you all. Have a great weekend. Okay. Do let me know if you have any questions. Thank you, Yamuna. Thank you, Amber. Thank you, Janani. Amber, regarding what do you want to reach out to me? I have given you mic access. Do you want to talk? Okay. You are applying for MTech. Okay. So how can I help you regarding that? Do one thing. You can send me a brief email. Okay. I'm just putting down my email address. Okay. You just send me a detailed email regarding what exactly is required from your end. Okay, and I'll help you out. Okay. I put my email in the chat box. Yeah. Thank you.